Eric Burgess here, a meteorologist who sampled 10 randomly selected thunderstorms, found that the average speed at which they travel across a certain state was 15.8 miles per hour. The standard deviation of the sample was 1.8 miles per hour. Find the 95% confidence interval of the mean. All right, cool. So confidence interval question, pretty easy to identify because they actually use the words confidence interval, as it says right here. And they even give us the statistics. So let's pull those out real quick. So we have 10 randomly sampled things. So that's n is equal to 10. And then sampled thunderstorms, they traveled. And okay, so they say the average speed, so we're looking at some sort of a mean here, which they traveled was 15.8 miles per hour. Now this average speed, was it a population average or a sample average? Well, looking at this, it came from these 10 randomly selected thunderstorms. So this is a sample average that we were given. So we have an X bar, which is the sample average, 15.8. The standard deviation of the sample. So they even tell us right here, it's a sample standard deviation. I love it when they're this clear. So when it says it like this, we know that this is just going to be an S because it's a sample standard deviation. That's 1.8 miles. And because we were given a sample standard deviation, we also know we're using a t distribution. And also our n is also very low, which is another clue. Now find the 95% confidence interval. So if we have a 95% confidence interval, that means our alpha is whatever's left. In this case, it's 0.05. And we know that all confidence intervals are two tails, right? Because there's some, we have a true mean, and then there's going to be stuff below it, and there's going to be stuff above it. And because of this, there's going to be half of the alpha is going to be below, half is going to be above. So our alpha over 2 is going to be 0.025. And again, I recommend just really quick typing it in and dividing by 2 just to be extra safe that you didn't miss a decimal or something. So we get alpha over 2 is this, and this is the alpha we're going to use for our t-score. So we can do this directly using the calculator, or we could use the formula. We know we want the t formula because we have a sample standard deviation. And so recall that our formula is simply the point estimate, and our best point estimate is always going to be just our sample mean, whatever study we did and data we collected. And then there's going to be minus some error. In this case, the error is according to a t distribution. So the error's expression is this. And then we're going to have the sample mean, our estimate, plus the error. So this is going to be a little above the mean. It's going to create an interval for us divided by the square root of n. So this is the formula you'd want to go look up if you don't just know it off the top of your head or how to think of it. The way I think of it is the way I just explained. That's how I kind of remember it. But every now and then I'll need to go look at a formula sheet because I just forget. So let's go ahead and dive right in and do this. So we're going to do it using the calculator first. So it's a t interval, so easy peasy. We go to stat, we go to calculate, not to calculate, we go to tests. And we want to go to a t interval, which is number 8. In here, we were given statistics, thankfully. So we're going to go over to stats, and we're going to type this jazz in. So first up, n is 10. Our x bar is 15.8, so we type in 15.8. Standard deviation was 1.8. Our n was 10. Oh, that does not change. That's convenient. And we're going to come down to our confidence level, which was 95% confident. So we're going to type 0.95. The calculator doesn't require the alpha or alpha over 2 like the formula will. We hit calculate, and it gives us an interval here, an interval notation. So this is the lower side. It's the side that goes with this. And this is the upper side. It goes with this. So we would say that the true mean lies between 15.51, then there's the mean, and we're rounding, of course, 17.09. And writing this is great, but it's usually a good idea to include a sentence showing that you know how to interpret this, because other than that, it's just like numbers and symbols and stuff. So how would we interpret this? Well, they wanted to estimate the average speed that they travel across a certain state. So we would say the average And in fact, we're not just saying any average. We're saying the population average, or the true average, that I'm going to call thunderstorms just TS. Thunderstorms move across the state is between, and what were our numbers in? They were in miles per hour. We can see right here, miles per hour. So they were between 14.51 miles per hour and 17.09 miles per hour. So this is how you would write your answer. I would include both, definitely. You need this, and the sentence is a really good idea just to show. And if I was doing this on an exam and I wasn't explaining all this, this would probably be done extremely quickly if I was allowed to use the calculator, because it just pop it in, write the interval, write the sentence, moving on. Like it's a super quick problem. But let's say that we want to use the formula to double check our work. Maybe we have some extra time, or maybe it's required by the teacher. No big deal. All we got to do is plug it in. We do need to find t of alpha over 2. So using the calculator, we can get this just using an inverse lookup. So we're going to come in and we want to use a distribution because it's a t distribution. And the area that goes with it is an area in this t distribution. So we're going to choose this blue one. So we hit blue distribution. And we're going to come down to inverse t because we have an area and we want a t-score. And so that's going backwards. So we call it the inverse. And we want an area of, what do we want? 0.025. 0.025. We're going to do alpha over 2, not just alpha, because it's been split in half. There's half below and half above. Degrees of freedom is 1 less than n. That's still 9 because our n was 10. And we hit paste. And what do we get? You hit enter again and we get negative 2 point blah, 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 blah. So we get t of alpha over 2. That looks like alpha over alpha, but it's alpha over 2 is negative 2.26. All right. Now, let's say that you want to use the chart. You're a chart kind of a person. No problem. What we're going to do is we're going to look up 0.025 in the chart backwards for a degree of freedom of 9 since our n is 10. So we come in here. Our degree of freedom is 9. And we're looking for 0.025 in one of the tails, right? Because in both tails, there was 0.05. So here's 0.025. And in one of the tails is 0.05. So this lines up perfectly with what we were looking at. So if we go ahead and just draw our lines here, we get a score according to the chart of, oh, that didn't circle very well, 2.262. So 2.262, let's come over here. And look at that. We get the exact same thing right here, 2.26. And if we keep going on the calculator, it would be 2.262. So I chose to round to 2 places. That's how you find it in the chart. Let's go ahead and dive into the plugging in now. So our x bar, well, that's just 15.8 minus t of alpha over 2. That's 2.26. And I should mention here that the 2.26 is plus and minus because the distribution is symmetric. So we only check the lower half, but we could actually get the positive half by doing 1 minus this and plugging that in for inverse t. But that's a lot of extra work for a distribution that we know is already symmetric. So we just take plus minus of it. And we do, okay, so we got 2.26, and then s is 1.8 divided by the square root of n, which is 10. Our mean is in the middle here, our true mean. And then this side's the same thing, but it's just got a plus sign this time, right? Because it's just plus the error. So 2.26 times 1.8 divided by the square root of 10. And what are we going to get? What are we going to get? So we're going to come in here. We type this in 15.8 minus 2.26 times, and it's 1.8 divided by, and we want the square root. So we hit second square root 10. Come out from under the square root and put it in parentheses. And that's how we type it in. We hit enter. And we get 14.51, exactly the same. And if we clone this, Now, in other videos, I recommend putting parentheses around this square root of 10. That's just because I've seen students mess up other problems. But in this particular formula, it actually doesn't matter. The order of operations will do it in the correct order for us already. But we want to change this to a plus for this side. Enter 17.09 when rounded. And so there you go. We get the exact same thing. Quick way to check our work and actually show just sort of, this is how you would do it if you didn't have a fancy dancy calculator to do it for you. And that's that. If you have any questions about this, let me know. Subscribe, and we will catch you in the next problem.